You're a hunter looking for the legendary two-tailed monkey in the dense forest of... Hey, look! As an experienced hunter, you know that the monkey has a trick up its sleeve. The second you shoot, it lets go of the branch it's hanging on to. So what do? It might seem like a good idea to aim slightly below the monkey to catch it on the way down, but gravity makes it so that you'll probably miss. The answer is actually pretty straightforward. Just aim right at the monkey because gravity will affect the bullet and the monkey in the same way. The firing velocity doesn't even matter. In order to mathematically prove this, we need to make sure two things happen. We use all the equations and make sure that all the variables equal each other, and the result of all the equations will be something that's true, such as 1 equals 1, or 2 times 20 equals 40. To create the equation in the first place, we need to draw the situation out. In this drawing, we have the monkey on a tree and a gun on the ground a bit away from the base of the tree. It's tilted upward at an angle, theta. The distance from the gun to the base of the tree will be known as A, and the distance the monkey has to drop will be known as B. This creates a pretty neat triangle that we'll use later. In this next drawing, we have the gun. The firing velocity, which is also the initial velocity, is known as V0, which signifies the direction and magnitude of the bullet when it leaves the gun. Using trigonometry, we can calculate the x component of V0 is equal to V0 times cosine theta, and the y component is V0 times sine theta. These values will be important when we create our equations. In order to create those equations, we use the formula d of t is equal to V0 times time plus 1/2 acceleration times time squared. The first equation will have a y value of the bullet at a certain time. The value of acceleration will be that of gravity, about 9.8 meters per second squared, represented by a g. We'll use the y component of the firing velocity because we're finding the y value of the bullet. When you plug in that information, you'll get negative 4.9 t squared plus V0 times sine theta times t. To do the same for the monkey, you don't need an initial velocity because the monkey doesn't have one. It just falls down because of gravity. Keep in mind that with respect to the y value of the gun, the monkey's b units higher. We'll have to specify that in the equation. If we plug in everything we know, we'll get negative 4.9 t squared plus b. Let's go back to the bullet. For initial velocity, we'll use the x component because we're finding out how far the bullet travels in the x direction. Since the bullet isn't affected by gravity and has no acceleration of its own, the value will be 0. And we'll be left with a simple equation of V0 times cosine of theta times t. The monkey's equation is even easier than that. Because the monkey is moving in only one direction, down, there will be no change in x. The equation is simply the value of a at any time. Now we have to put all the equations together and make sure that all the variables are talking about the same thing. We can begin by having all the equations that have to deal with y equal to each other. If we simplify it down a bit, we'll end up with V0 times sine of theta times t is equal to b. Now we can mess with the x equations to see where that takes us. V0 times cosine theta times t is equal to a. Since the t in both equations needs to be the same for this to hold true, we can solve for t in the second equation and plug that in for the value of t in the first. This leaves us with tangent of theta is equal to b over a in the end. Is this true? You bet. Check out the first drawing we made and you can see that this equation really does work. Pretty neat, huh?